This is an HP 3000 Series 42. This is the System Processing Unit, or the SPU, which has the CPU, memory, and I/O system channels in it. On top we have a couple of 300 megabyte disk drives. We'll show those in a minute. We have a system console, which is just a serial terminal. And then we have a streaming tape drive, HP 7980 tape drive. And we'll see inside that there have right here a run button that's used to boot the system, a halt button to stop the system, start, dump, and load. Start with a corresponding channel and device number down here. Start is used to boot the operating system from disk. Dump is used to take a memory dump, and that's usually to disk. We see both the start and the dump device have channel 11 and then device 1, so they're both going to disk. And then load is usually comes from magnetic tape, and that's where it's going to come from in our example here also. And there is a keyed switch that has various different hardware security levels on it. Secure, so no functions can be performed from the front panel. In other words, these buttons are turned off. Control on, these buttons are enabled. Control on and maintenance on, and then remote on down here means we can use a remote console. There's also some lights. Activity light, when the CPU is doing some work, this light will be on, and if the system is using its battery backup, this light will be on here. So next what we can do is actually power on the system and see how that works, and see what happens when the system is first powered on and starts to use the CMP, or the control and maintenance processor. So this is the back of the SPU, and we can see here there's the card cage for the CPU and the channels. Up here is where the front panel logic and some cooling fans reside, and then down in the bottom is the power supplies for the CPU, and then there's some empty space for I/O cables and such. And if we look at the card cage from left to right, the first 5 slots, 1 through 5, are reserved for memory. In this system we have a 4 megabyte board, and we have a memory controller, and there's a back plane on the other side of the boards back inside, and then we also have these ribbon cables connecting different components. And then this slot, slot 6, is where the control maintenance processor goes. There's a ribbon connection between the CMP and the other 2 boards that are part of the CPU. There's also an I/O connection for the CMP, and this goes to the datacom channel, which goes to the console. And then we have different ribbon cables connecting the CMP. In slot 9 we have the ALU, the arithmetic and logic unit, and then we have the CPU control sequencer board that's in slot 11. And then slots 13 through 25 are for I/O boards. In this system we have these 2 boards, in 13 and 14 are the ADCC, that's our datacom controller. So we have a cable that goes down to the junction box. The ADCC actually takes 2 cards, and these are connected together with this ribbon connector. These hoods here go to cables that go out to those junction boxes for the serial cables. The next 2 cards in slots 15 and 16 are GICs, general I/O channels, and this one here goes to, let's see, that is channel 9 and then channel 11. So this is going to go to, let's see, this is where it okay, this goes to disk, this goes to tape. We have another ADCC for serial datacom. And then we also in this system have what's called an INP, an Intelligent Network Processor. And this board here, the INP, can't see that very well, but that board is basically a smart datacom board for networks like for serial networks that use serial protocols. So here's another system. I just want to show an example of a system. Instead of having one 4 megabyte board, this system here has 4 1 megabyte boards, but the same memory controller, and then all of these would be connected by a flat ribbon cable. So we're going to start by turning on the SPU, and Michael, can you go ahead and do that?
Now can I go?
Yes, now you can go. Thank you.
Yay!
And then it has the prompt, and this prompt and the console talking directly to the hardware control maintenance processor right now. We can display a list of commands that we can do from the CMP from here, and for example there's like a datacom test, display displays contents of internal registers. That's basically the hardware state of the machine. There are a couple of commands that we'll do, IO map and self-test. IO map shows us what our IO configuration is on the system. And what this is telling us is that we have 4 meg of memory. Our start and dump devices are configured on channel 11 device 1. Load device is on channel 9 device 1. And we have 4 channels, 4 hardware channels in the system. Channels 1 and 2 are datacom channels, and then channel 9 and 10 or GICs, or general interface channels. We can also do a self-test, which just runs through and does basic health checks on the CPU and different components, and the SPU and different components in the SPU. So our system test passed, but let's look at that. And so if we go down and look at the results, the first thing that gets tested is the CMP, its RAM, ROM, and datacom tests pass. Then it tests the interface between the control maintenance processor and the actual CPU, and that test passed. And then the CPU will do a set of internal tests, and then we're going to, then it's going to do a set of tests on just the channels that we use to either talk to the console, which is this first ADCC here, and then the channels we use to either boot or load the system. One of the things that we can do with self-test command is use it with a parameter, and here I specify a parameter of 0, so that's going to run the self-test command essentially an infinite number of times, either until I turn the power off, or it gets an error, or I enter the control B command, which is the interrupt command. So we'll just let that run a couple of times. We can see what that looks like. Okay, so our tests keep passing, and we're going back and running the tests again. So I'm going to hit Control B on the keyboard. So it's going to run through and finish the set of tests that is currently on, and then we'll get the prompt from the CMP. So one other thing that we can do, which is fairly interesting with the IO map, IO map will show us right now the devices that are connected to the channels are turned off. So when it gives us the hardware channels that are actually physically present in the system. It shows the channels, but it doesn't show any devices. So if we go and we turn those devices on, and what I'm going to do is I'm going to turn on the disk drives and turn both of these on. And you see they're going to do their startup. They're doing their self-test right there. And when they finish their startup sequence, that light's going to be solid green. For both of those. And each one of these boxes here has about 300 megabytes of storage in it, and they're both connected through HPIB interface. So we have two disk drives. Those are connected to channel 9 on the channel 11, our start device. And then I'm also going to start up the tape drive here, 7980, and then it's going to go through its startup sequence. It does a power on self-test. Okay, that passed, and so first thing it's going to try and do, this is an auto-loading tape drive, so it's going to assume there's a tape in there. That's going to fail though, that's fine though. Then let's go back and look at the console, and what we want to do is run the IO map command with, now that the devices are on, and we should see the devices actually listed. So 4 meg of memory again. So now it's showing us we have these ADCC channels. That's not going to go out and look at devices, but on channel 9 we have a device number 1, or unit 1 has an ID of 180, and that's our tape drive, ID code for our tape drive. And then channel 11, the GIC, has a device with a unit number of 0 and a device with a unit number of 4. And those are both ID 22Es, and those are both disk drives. So the device number 0 or 4 is actually set by a thumb switch on the back of the hard disk drive. So this is the back of the SPU, and we can see here there's the card cage for the CPU and the channels. Up here is where the front panel logic and some cooling fans reside, and then down in the bottom is the power supplies for the CPU, and then there's some empty space for I/O cables and such. And if we look at the card cage from left to right, the first 5 slots, 1 through 5, are reserved for memory. In this system we have one 4 megabyte board, and we have a memory controller, and there's a back plane on the other side of the boards back inside, and then we also have these ribbon cables connecting different components. And then this slot 6, is where the control maintenance processor goes. There's a ribbon connection between the CMP and the other 2 boards that are part of the CPU. There's also an I/O connection for the CMP, and this goes to the datacom channel, which goes to the console.